In this hopefully brief video, we're going to go through implicit differentiation, and I'm going to go through maybe 3 or 4 exam questions, which you guys and girls can go along and fill this out with me. Hopefully this helps you at the end of the year when you might be forgetting things. Now, first of all, as I've discussed, whenever we see an equation, it's asking us for dy dx, or in this case, it's asking us for the equation of a tangent. It could also ask us for the equation of the normal or the gradient of the normal. It can ask you for many different things, but it all requires implicit differentiation. Whenever you see x's and y's on the same side, and you're trying to find the dy dx or something relating to that, we need to use implicit differentiation. So the first step, as I have said and I went through before, is that we need to derive both sides with respect to x. So we're going to do that, and we're going to open up a bracket, and we're going to do it like this. And as I said, we're not going to invent our own ways of doing things. We're just going to do it the way the textbook and your teacher has shown you, because of course there's no way you can lose any marks if you do it this way. I've seen some crazy ways. Now, just quickly, I want to change it to, I've jumped the gun a little bit. Now, and the good thing is when you're doing this, you can then sub this point in that we've been given, and you'll find that it's a pretty easy 4 marks. Well, this one's 3 marks. So we could probably do this in about a minute and a half once you get good at it. Now, the derivative of x cubed with respect to x, that's easy, isn't it? That's 3x squared. But here's the trick. What we've got over here is this is the product rule. Okay, so what we're going to do is, so it's, 3x squared, and the product rule is what we're doing is we're doing the derivative of x squared or minus 2x squared with respect to x, which is minus 4x. Then we're multiplying it by y, so the answer is minus 4xy. And then the other one, we're doing the derivative of y with respect to y, which we call dy dx, which we've been through. And then it's times minus 2x squared. So it's minus 2x squared. We'll just do it like this, dy dx, like so. That's fine. Now, the trick is as well is that 2y squared. Let's just do it over here. D by dx of 2y squared. Whenever you forget how to do this, I want you to think about the chain rule. So what we've got is we've got a d there, we've got a dx there, that missing variable being y, and you've sort of got this, like so. Now, in actual fact, it would make sense to put that there. We want the derivative of y or with respect to y of 2y squared. So what that's going to be is that's going to be 4y, and then of course that dy dx doesn't go anywhere. Do y dx like so. Now we're going to insert this over here. We've got plus 4y dy dx, and of course the derivative of 2 is 0. Now what we need to do, it says here at the point 23, and that's really important because it says find the equation of the tangent. Well, the equation of the tangent is y equals mx plus c. So in actual fact, the equation of the tangent is literally just the derivative at that point, like so. So that's all it is. So now what we can do is we can sub in 2, 3. So at 2, 3, what we can say is that minus 4 times 2 times 3 minus 2 times 2 squared dy dx, when you sub it in, it becomes much easier. Plus 4 times 3 dy dx equals 0. Can you see there we're writing dy dx a fair bit now in this example? So what you could do is what I tend to do is I tend to say let y dash equal dy dx, and if you do that to begin with, you can replace all those dy dx's with y dashes. Okay, but we'll continue. We don't need that for now because we've just gone through all that effort. What's that? We've got 6. That's minus 24. What's that? 4 minus 12 dy dx plus 12 dy dx is equal to 0. If I got that right? 2, 8, 24 minus 12. So what have I missed? Oh, that's 8. I was going to say, like, that can't work out. There we go. So that's so now what we've got is we've got 4 dy dx is equal to 24. So therefore dy dx is equal to 6. And of course, so therefore what we can say is the equation of the tangent. So therefore we've got y equals mx plus c. And isn't that equal to 6x plus c? And can't we just sub in that point at x equals 2, y equals 3? So we've got 3 is equal to 12 plus c. So c is equal to minus 9. So therefore the equation of the tangent is y equals 6x minus 9. Like so. All right, now let me just pause that. Okay, so just looking back at that, way over here didn't have that 3x squared. So clearly that's a bit of a blunder on my behalf. So let's go over here and change this a little. So 3x squared when x equals 2 is 3 times 2 squared, which is 12. So there's a 12 over here. Okay, like so. So what we've got is we've still got 4 dy dx, but what we have is 4 dy dx is equal to 12. Yes, 4 dy dx. So dy dx is equal to 3, like so. Can you believe I didn't actually bring that down? Quite easy to do. Okay, so 4 dy dx is equal to 12. And so now what we've got is y is equal to 3x plus c, and then we sub that in at so x equals 2, y equals 3. That's going to be 6 plus c. So c is equal to minus 3, like so. Can you see there that I knew exactly what I was doing, but I made a silly mistake. If you were in the exam, it's very easy to do, especially under the heat of the. Like, I'm presenting to you guys, and I've done this stuff over and over again. If I can make a mistake like that, so can you. So it's so important to actually go through and check each and every line of your working if you have the time. The question is if you have the time. If you really know your stuff, you could probably finish this exam about 10 minutes early at least, if you really know your stuff. All right, so let's move on. That was almost a big monumental mistake on my behalf there, simply because I didn't bring one thing down to there. So setting out is actually really important as well. Now, it says here, given the relation, find the gradient of the normal. You have to read these questions very carefully, the normal. So just quickly with this, let's do the same thing. D by dx. Just quickly, I'm trying to explain and do this without looking at answers or solutions. Maybe I might not make as many mistakes if I didn't have people speaking over me. All right? If you have a question, ask it. I can pause it. But please, I'm trying to learn Mandarin at the same time. It's ridiculous. Okay, 3x squared plus 2xy plus y squared is equal to d by dx of 11. So set it up like this. Now, once again, as I said, if you wanted to change and let y dash equal dy dx, go for it. If you don't, that's fine, but you'll need to write your y dx. Okay, so because that's the notation we've used. Now let's take our time with this. The derivative with respect to x is 3x squared is 6x. That's nice and easy. And the derivative of 2xy. Well, the derivative of 2x is 2. 2 times y is 2y. The derivative of y is y dash in this case. And we're multiplying or adding that to 2x. So 2x y dash. And as we have discussed, the derivative of y squared, this is the one that students muck up, that's going to be 2y dy dx using the chain rule that we just discussed. So we've got, in my case, 2y, y dash. And of course, the derivative of the right-hand side is 0. Now, it can be really important to, you can sub in points, but it says here in the first quadrant where x equals 1. So find the gradient of the normal. So what we could do is, I'm going to rearrange and get y dash. I can do that first. So let's get everything with the y dashes on one side. So we've got 2x y dash plus 2y y dash is equal to, and we've got minus 6x minus 2y, like so. Now I'm going to divide both sides by 2, and then that's going to give me xy dash plus y dash is equal to minus 3x minus y, like so. And I'm going to take x plus y out as a common factor, and what that leaves us is this, minus 3x minus y over x plus y. So therefore, there's my gradient function. But it says find the gradient, the gradient of the normal at the point where x equals 1. But in order to do that, in order to find the gradient of the normal, we need to find out what y is at x equals 1. So what we're going to do is I'm going to stop there, and we're going to say that at x equals 1, 3 times 1 squared plus 2 times 1 times y plus y squared is equal to 11. Let's see if that works out all right. We've got 3 plus 2y plus y squared. Let's get the 11 on this side, shall we? So we've got minus 11 is equal to 0. I reckon, can we factorise? Y squared plus 2y minus 8 equals 0. Now we're going to have two values of y, but it says here that, and this is where you really have to read some of these, this question would have been one of those ones not done so well, I would have thought, because there's more chance for errors. So we're trying to find in the first quadrant. Now I'm assuming we can say that y plus 4, y minus 2 is equal to 0. So therefore, that y is equal to, it's 2, and what we can say is that it's since the first quadrant. Okay, so that's our y value, and you've just justified why it's our y value, so that's fine. So now what we can say is that y dash is equal to y dash, or we can say at the point 1, 2, we can say that y dash is equal to minus 3 minus 2 over 1 plus 2, which is equal to minus 5 over 3. Now, the question is, have we answered the question? No, because what we can say is we've found this basically. Okay, we have found minus 5/3. What we need to find is M2 such that that is the case, because that's the gradient of the normal, isn't it? The gradient of the normal is M2. So therefore, what we can say is that the gradient of the normal is what's that? 3/5. And that should be done. Now let's have a look. That's 2008 exam 1. Let's just go and pause this for a second. Okay. Did I just stop that? So as you can see, this is the answer 3/5. Most students did that fairly well. But given that you know it's on it every year, shouldn't that be higher? I would have thought so. I would think that you get that 99 times out of 100, I'd hope. If you don't make silly mistakes like me. Okay, let's do another one. Now I'm going to pause this, and this time I'm going to give you a go. Okay, now, forget that one. That's a bit easy. This one here, okay? I'm going to pause this now. You guys can have a go at this one. If you're watching the video now and you haven't seen this for months, have a go at it now. Let's go. All right, so we're going to do this as fast as we can, and I'm going to do this before you guys go to recess. So I'll just hit the stopwatch. Let's go. First of all, we're deriving with respect to x both sides. Like I said, we have to write that. We have to write that out, like so. So we're going to do that, deriving with respect to x, no skipping any steps, plus 3x minus 4. Now the derivative of y is y dash, so I'm going to let y dash equal dy dx. That's just something that I like to do. So the derivative of that with respect to x is, so therefore what we have is, we have y dash log e to the x plus 1 on x, the derivative of that times that, y. And that is equal to 2e to the 2y, y dash, plus 3, like so. And now what we're going to do is evaluate do y dx at the point 1, 0. So what we're going to say at 1, 0, we're going to just sub it in to make our lives easier. Because when I sub in 1, 0, what that leaves me with is it leaves me with y dash times log e to the 1 is 0 plus 1 on 1 times y, which is 0, is equal to 2e to the 2y, which is 0, 2e to the 0, y dash, plus 3. Now, so what does that leave us with? It leaves us with minus 3 is equal to 2y dash. Y dash is equal to minus 3 on 2. Is that what we got? Yes. Now, I just did that with explaining it in 2 minutes. So look at that, 4 marks in 2 minutes. That one was a pretty easy one, and there was no real reading surrounded by it or anything like that. As you can see, that one is pretty straightforward. Like I said, this stuff needs to be mastered at the end of the year. There's no surprises. Really, you're going to have 4 marks on every year's paper, and it's around this. So make sure we get it. Thank you.